You have in the past solved quadratic equations such as 5x squared minus 4x minus 1 is equal to 0. What if this time around I ask you to solve the expression 5x squared minus 4x minus 1 is less than or equal to 0? In other words, I want you to find all the values of x which will ensure that the left hand side is always going to be smaller than or equal to 0. It's very easy to assume that the process that you carried out in solving the quadratic equations is still the same process that you have to employ in solving this inequality. I'm going to first of all go ahead and use this incorrect method of treating it as an equation, and then I'm going to show you why it fails. So in solving the quadratic equation, what I would want to do is factorize the left hand side of this expression, and you will be able to see that it factors into 5x plus 1 multiplied by x minus 1, and I'm going to keep that as less than or equal to 0. If you're unsure of how to factorize this left hand side, please visit my channel and you will find a video that deals with the factorizing of quadratic expressions. As I said, someone would think that now because we factored it out, it follows that 5x plus 1 must be less than or equal to 0, or x minus 1 has to be less than or equal to 0. Isolating x on this first expression means that x must be less than or equal to minus a fifth, or x has got to be less than or equal to 1. If I draw a number line for the two solutions, if this is the x here, and I'm going to draw a number line for this one here as well, you will notice that if you've got your 0 here, minus a fifth is going to be somewhere there, and obviously that is x, so we are including the minus a fifth, so it means we are taking all the numbers which are on the left hand side of minus a fifth. Similarly, on this side here, if 1 is there, we are looking for all the values including 1 which are going to be on the left hand side of 1, so all the values which are less than or equal to 1. Combining the two solution sets, you will notice that this one is a subset of the second inequality. So therefore, we are saying using this method that x has got to be less than or equal to 1. Now, if I choose any number which is less than 1, for example, if I say that x is equal to negative 10, because negative 10 is definitely less than 1. This expression here is going to be equal to 539, a number which is definitely greater than 0. So it means that this method that we have used is incorrect. So how do we actually solve this expression? Let me start on this side of the screen. So we've got 5x squared minus 4x minus 1 is less than or equal to 0. We are definitely going to need to factorize the left hand side, so that is still 5x plus 1 multiplied by x minus 1, and that's less than or equal to 0. At this point we need to find what we call critical values. And these are the values which will make the left hand side equal to 0. So we equate the left hand side to 0. So at this point we are saying they occur when 5x plus 1 multiplied by x minus 1 is equal to 0. Therefore, this tells us that x is equal to minus 1 over 5, or x is going to be equal to 1. We now sketch the graph of y is equal to 5x squared minus 4x minus 1, and then we're going to explore its behavior at these two extremes. We all know that it is going to be a parabola which is going to look something like that, intersecting the x-axis at minus a fifth at this point, and intersecting here at 1. Now this is y is equal to 5x squared minus 4x, minus 4x minus 1. Now we're saying as we move along this value at different x values, y is going to take a position or a value which is defined by this expression on the right hand side. So at this point the y value is going to be above the x-axis. If we draw a random y-axis, let's say it's going to be somewhere there. As we explore, the y values are positive there. At this point y is equal to 0, and below the x-axis y is going to be negative. So we are looking for values of y along the curve which are going to be less than 0. And I think you will agree with me that this is satisfied between minus a fifth and positive 1. The graph is below the x-axis as I start from minus a fifth all the way through until I get to positive 1. And beyond positive 1, the graph is above the x-axis. So how do we put the solution? We are going to say that the graph is less than or equal to 0 if x is greater than or equal to minus a fifth and x must be less than or equal to 1. And so this will be the solution, or this is the set which gives all the values of x which satisfy this inequality. In the second example, we want to solve the inequality 2x minus x squared is strictly greater than 0. Now we're going to proceed in a similar manner by factorizing the left hand side. So we pull out an x as a common factor. 2 minus x must be greater than 0. We then look for the critical values, and these are going to occur when x multiplied by 2 minus x is equal to 0. And then you'll find that x must be equal to 0, or your x has got to be equal to 2. I'm going to go ahead and sketch the graph here, and because the coefficient of x squared in this expression is going to be -1, the graph is going to be a parabola which is upside down. Well, it's going to look something like this. And we've just seen that this point here is going to be 0 and that point is going to be 2. So that's your y-axis and this is your x-axis. So we are looking for the values of y because this graph represents y values at different x values. So where is y going to be greater than 0? So in other words, where the y value is positive. So if I choose an x value here, for example, I choose an x value here, the corresponding y value is there, and that is above the x-axis and it's a positive number. If I choose an x value on the left hand side of 0 and I touch the graph at that point, the corresponding y value is going to be negative. So you will notice that the positive values of y correspond to when the graph is above the x-axis. So our solution set then is going to be 0 is less than, strictly less than, because our graph, our initial question requires that the left hand side must be strictly greater than 0. So 0 is less than x, which must be also less than 2. So that's your solution set. Before we look at our final example, we are in a position to make a generalization now after having done these two examples. So if you're required to solve a quadratic inequality of the form ax squared plus bx plus c, and you're required to make it greater than or equal to 0, after sketching the graph you look for where the y values are above the x-axis. So graph must be above your x-axis. The second scenario that we have seen is that if you want to solve ax squared plus bx plus c and you want it to be less than or equal to 0, then your graph must be below the x-axis. Okay, so we're going to look at one final example, and then I'm going to ask you to try this one out on your own before you play back the video, and then you compare your solution against mine when you're ready. Okay, let's make some space here. And so your question number 3 is solve the inequality x squared minus x minus 2, and we want to make this one greater than 0. So I'm going to give you an opportunity to pause the video now. Welcome back. I trust that you had some success in solving this inequality. So let's get to it. What we want to do is factorize the left-hand side, and I think you'll show with relative ease that it factorizes into x plus 1 and x minus 2. And so your critical values are going to be equal to x is equal to -1, or your x is equal to 2. So I'll go ahead and sketch the graph. In this case, the coefficient of x squared is equal to 1, so it's a parabola that is going to be facing up like that. And if we suppose that our x-axis runs through at that point, so it's going to cut at your critical values, which we've found to be -1 and +2. Now we are looking for parts of the graph which are above the x-axis. Now if I choose a point here, you will notice that the graph is now going to be below the x-axis. I'm looking for parts which are above the x-axis. So if I go up here, that is above the x-axis. If I choose something here, all this in here is below the x-axis. So the y values that we're looking for are here and also on this side. So we are saying that x has got to be less than -1, or x has got to be greater than 2. Okay, this brings us to the end of the tutorial. Thank you for watching, and we'll see you in the next one. Cheers.